Good evening, all. So, I am Anand. I'm a senior architect from Tata Elxsi CTO office. So, myself and my colleague Deepika, we are going to present the demonstration of Charmed 5G deployment. So, okay. So first we will take you through that first presentation followed by the demo. So the first we will try to cover the system overview, and then followed by scenarios and configurations, what and all we are doing as part of this demo. And then we will zoom into the details of what are the components and how the deployment is done, and along with the parts and Charmed's view. So this is how we structured this session. So first we will get into the high-level system view. So this is our system. So if you see at the bottom, so we have 5G components starting from a RAN emulator and then 5G core, and we have also leveraged IMS. So all our so except RAN emulator, remaining things are whatever we are seeing is completely open source based. So we have leveraged free 5G core for the core, and we leveraged the KNF for the IMS. Okay, so there's RAN emulator. Yeah, we have just took the model reference of free 5G script, and then from there we completely developed this RAN emulator from the scratch. So this is the a component with respect to component level. And then here we are leveraging the Charmed OSM for the deployment with the help of Juju controller. As you know, Charmed OSM is a lightweight and young model based. It's a completely effective orchestrator. So we leverage this with the help of Juju controller. It's a more powerful modeling tool. So like we saw the presentation from Mark. So it's very powerful. It's operating. So it's providing the modeling, especially for the relations and then operations, various operational events, right? So it provides a very effective modeling tool, especially the complex system where it has so many dependencies. The components are interrelated, and then a lot of interrelated and not isolated environment to provide the service. So we have a challenge in the modern world. So it addresses that. So we are leveraged with the help of Charms, and we have also used a micro-KS as a infrastructure manager. Okay, so this is the view. So if you see all the components are deployed as KNFs, all the independent pods. So all are connected through the interfaces. So here we are going to demonstrate the deployment as well as control plane and data plane of 5G scenarios. So like I mentioned earlier, so three components, the scenarios for these three components deployment along with the configurations. It includes both the day one and day two configurations, and then followed by the scenarios 5G user registration, and then followed by internet traffic flow. It covers all kind of protocols, UDP, TCP, and ICMP. And then finally, we are going to demonstrate voice traffic flow, the RTP packet flow. Okay. So with respect to configurations, for the RAN, we need to have that GNB configurations like all the tracking area code, and then PLMN ID and eNodeB identifier. All these configurations made through this Charmed framework. Okay, so then the UE configurations, especially the IMSI number and other details like security parameters, OPK, all these parameters needs to be configured. So that is also done through this platform. And then finally the SCTP trigger. This is to connect with the core for the NGApp messages. So these are all the configuration parameters with respect to RAN emulator. And core, similarly, the data path configurations, we need to have some the source NATing, all other parameters, the IP table rules. So all things are done through the this platform. along with the subscriber information. Here also it requires IMSI number, all this thing, all the user details along with the slice information. So when it comes to IMS, here the subscriber information means the domain name, what domain name the customer needs to use, and then user credentials. All this information can be configured along with the DNS configuration. So here DNS more specific to the intermodule communication. So all the pods inside IMS needs the domain name for the communication. So it requires DNS configurations as well as domain name. So this and all configured as part of IMS, so that we will see it as part of the demo. So this just to zooming into that components, whatever we have seen earlier. So here the packages are from all the network service descriptors along with this function descriptors are available with the OSM. So that will help us to deploy this 3 independent clusters. Okay. So RAN as a cluster, independent cluster, core and IMS all are independent clusters. So if you see all the clusters, so we have a cube load balancer that will help to connect the components across the clusters. Okay. So for this RAN and core communication, as like I mentioned, the SCTP connection is required for the control plane. That's also using the standard port as per the 3GPP specification. Similarly, for the data path, we need a GTP connectivity, GTP port listen. Okay, so it's a 2152. So this is how the connectivity between RAN and core. Similarly, to connect to IMS, so we need to have a 4070 port to be listened. Okay, exposed to get a connectivity. So all the applications are at the RAN emulator side. So it's part of the UE app pod. So that will trigger the data path. So that will go through the UPF as the data path component. So it will reach the it will try to reach either the data network one, it's internet connectivity, so where web server will be live, and the second part is a SIP client. Okay, so for the SIP we have a separate data network, so the data path is connected to the other side of the SIP client. So this is the component view of each every clusters. So as part of the 5G. So with that, yeah, with that I will hand over to my colleague Deepika. So Deepika will take care of the further slides and demo. Okay. Deepika, are you ready?
Thank you, Anand. Yes, Anand. Anand, is my screen visible?
Yes, yes.
Okay. Hello, everyone. I'm Deepika from Tata Elxsi. Let's continue with the presentation. So this here is the deployment view. And you can see here, this over here is the external network to which all our clusters and the Charmed OSM are connected. As you can see here, there's a core cluster, RAN cluster, and IMS cluster. And taking a deeper look at the core cluster, we can see the core pods here like AMF, SMF, UPF, and NRF. And these pods, they communicate with 2 ways, where one is they communicate with each other using the Kubernetes network, which is represented here with this orange solid line. And with the external network, they communicate through the Kubernetes load balancer service, which here is represented with the blue dotted lines. And if you see the RAN cluster, it is the same there, where RAN is the one that needs external access. So that connects through the load balancer service to the external network. And IMS, there's a pod named PCSCF, which is connecting to the external network to the load balancer service. So that's all about the deployment view. So this here is the pod level view of RAN and core clusters. The RAN, the first image here is the RAN cluster, where you can see the RAN pod. And since we're using Juju operator framework, you can also see that there is a RAN operator pod. And you can see that this RAN pod also has services. Like this is a cluster service, this is a headless service, and this is a custom created load balancer service to expose an UDP port. And just like that, you can see over here that this is for the AMF, that is the core cluster, and you can see here as well that there's an AMF pod and there's an AMF operator pod, and we have all the services here as well for AMF. So this is about the pod service view. Let us get deeper into the charms views. So as we can see here, this is the charm structure we'll be using, and this is the charm that helps us to deploy and configure our pods. So this here is the actions.yaml where we can configure our day 1 and day 2 actions, and this is the configuration file over here. And in metadata, we can specify the type of deployment that we are going to do. And there's a source folder here which will have these two files, the charm.py and podspec.py, where the charm.py, the configure pod function is going to call the make pod spec, and where we can give the ports we want to expose, or the services we want to create, or the command that has to be run as part of the application. And also in this core, we had a scenario where we needed where two pods were dependent on each other. For example, like here, the one here, the SMF was dependent on UPF. UPF had to send its IP over to SMF so that the SMF can start. We achieved that using Juju relations, and these functions here: relation changed, relation departed, and relation joined. And as SMF is the one that is requiring an IP from UPF, we have configured it as the requires part of the Juju relations. And in UPF, since it is the one that is providing the IP, we have configured it as the provides part of it. So let us take a view at the KNF package. So this is the KNF package view of our setup. You can see the packages of RAN, core, and IMS here. And these are basically the bundle.yaml files that will deploy all the charms. And also these are the bundle.yaml files that will be referred in OSM's BNFT. First, let's take a look at RAN package. Here, it has two charm applications, RAN and UE, as we saw before that these are our 5G RAN applications. Then here is the core bundle where you can see all the core charms like DB, NRF, AMF, and also in the end you can see that there's a relations between SMF and UPF. And finally here is the IMS bundle where you can see all the IMS pods, where you can see all the IMS charm applications listed and also the relations between them. So that so all the required charms to deploy a complete setup is bundled up here as a package. So that being said, let's get to the demo part where we can see our Juju charms bundles and OSMs in action. So as a part of this demo, we'll be showing deployment of core RAN and IMS through Charmed OSM. And after it's successful, we can show you few 5G scenarios. So let's get to the demo. As I said, this would be the 5G deployment and configuration through Charmed OSM. So for that, first, let me deploy the core 5G core. So for that, I'm logging into my core user in OSM. So this is my core DNNSD.
And Deepika,
and I'll show you the VNF package.
Sorry, Deepika, there is some lag with your voice and video. So go a little bit slow.
Okay.
Yeah, now we could able to see your screen, OSM screen.
Okay. Okay. Thanks, Anand. So as of now, I'm going to deploy the NS descriptor first. I'm specifying a name there as core_DN, and I'm giving a short description for the NS deployment. And the NS ID is selected by default. And I'll select an Vim account, which is pointing to my core cluster, my microK8s core cluster. So now I have created the NS instance, as you can see here on the screen. As it is getting deployed, let me show you the VNF and NS packages. So this is the NSD here for core. which is referring, it refers to one of the only one VNFD called the core DN VNFD. So we have the network configurations here in the NSD and also the reference to the VNFD. So let's go to the VNF package to get more details. So VNFD, and you can see that it has only one KDU here named as the core KDU. And it has reference to the bundle.yaml that I was showing you in the PPT.
Deepika, sorry to interrupt. So your screen is struck. Okay, now it's there is a movement. Earlier it got struck. Okay, now we could able to see the VNFD. Yes.
Okay. So we have this was the core KDU I was talking about, and this is the bundle.yaml reference where all our charms would be referred. And this is the day one configuration. We have, as Anand earlier stated, we have a few route additions and IP table additions as day one configurations. So we have added it here, and I can show you the day two. The day two is a DB insert where we can add an user, IMSI or subscriber information into the DB anytime we require after the core is deployed. So we have added it as a day two operation. So let us go and check the status of the NS insert.
Hi, Deepika. Sorry to interrupt.
Yeah, hi.
Can you explain the NSD descriptor once again? I think I missed it because of the frozen screen.
Okay, yeah, I can go back.
Just the components, yeah. Thank you.
You need the NSD or the VNFD? You mean the VNFD,
NSD.
right?
NSD,
okay.
yeah. Yeah.
So this over here is the NSD where we have referred the core D and VNFD over here. Is it okay?
Okay. Okay.
Okay. Yeah.
Thank
Moving ahead. You're welcome. So moving ahead, let me go to the. So here the NS has started to deploy. I'll copy the NS ID so that we can see the micro K8 pods that are getting deployed. I'll put the command that we use to list the pods in micro K8s. So I've started a watch on the micro K8s commands. I hope it is visible. Some of the pods, core pods are coming up. You can see AMF operators. Yeah, now the most of the pods have come up. They are in the init state. Once they all go to running, let's go back to OSM and check for the NS status and the day one status. So you can see here that all the core pods are running. You can see UPF, DB, NRF, and all the pods. Let's go to OSM and check the status. So you can see that the NS has been deployed successfully. Let's check the day one also. You can see here that day one is also successful. I can log in into one of the pods, one of the core pods called as UPF, to show you what are the commands that get added in this day one action. So right now I'm trying to log in into one of the pods. So after I complete the commands, you can see that there will be 2 rules added for a specific subnet, that is the UE subnet 6060.0.0. Yeah, these are the 2 rules that would have been added in day one. So with this, our day one action is successful. We can move ahead to course day 2. So this is the core day 2 command. I hope it is visible. And this is the IMSI number or the subscriber information that we'll be adding into core. So this is complete. We can go back to OSM and check for the status of day 2 also. You can see here that day 1 and day 2 are completed successfully. So with this, our core is deployed and configured. Let's move ahead to RAN. Right now I'm logging into the RAN user in OSM. I'll show you the packages first. So first I'll deploy the RAN. I've given the name as RAN, and I was giving the description, and I'm selecting the Vim account that is pointing to my RAN cluster. So while it is getting deployed, let me show you the RAN NSD. I'm opening it up now. So this is the RAN NSD, and this also refers to only one VNFD called the RAN VNFD. You can see the network configurations and the reference to RAN VNFD here. Next, let's move to the VNF package of RAN. So this is a RAN VNFD. Here also we refer to only one KDU called as the RAN KDU. We refer to the bundle.yaml so that all the charms would get deployed in RAN. And we have a GNB config here as a day 1 action. And in this day 1 action, we would be configuring course details into RAN. We'll be configuring AMF details like AMF IP port, and then UPF port, DB details. So these are the other day 1 actions, and there's a day 2 to configure UE details into the RAN. So this is all about the RAN, NS, and VNF packages. We can go check our NS status again to see if it is deployed. You can see here that the deployment is in progress. So I'll copy the NS ID, and we can see the RAN pods being deployed. Right now I'm giving the microgates command here to list the pods. I'll also start a watch on it so we can see the pods getting deployed. So you can see here in the watch that the operator pods are up and the RAN and UE are coming up. And now all the RAN and UE pods are running. Let's go back to OSM and check the status. So you can see here that the deployment is successful. This here is the day one action that is also successful. Let's do the RAN's day two also, where we'll be adding the UE details into the RAN. So I'm currently copying the command here. You can see here that the UE management IP is being configured and the day two was also successful. I'll also log in into the RAN pod and show you the RAN logs. You can see here that in the VNFT we were configuring the core details, and you can see in the RAN logs that those IPs have been configured successfully as part of day one. And also as a part of day two, the UE context has been set inside RAN. So with this, our RAN deployment and configuration is successful. So I've logged into the IMS user now. This is the IMS NST and VNFT. Let me deploy it first. I'm naming this NS as IMS DN. So here I've created the NS instance. Let me run through the NSD and VNFT of IMS as well. So this is the IMS NST, and we'll be referring to the IMS VNFT here. I'm opening the VNF catalog now of IMS. So this is the KDU of IMS where we are referring to the bundle.yaml, and we have a set of day one and day two operations in IMS as well, where we'll be adding SIP users into IMS so that we could make calls between them. Let's go check the NS status. So the NS is getting deployed. I'll copy the ID so that we can see the IMS pods being deployed here. I'm starting a watch for the pods. So the IMS pods are coming up. So most of the pods are up. You can see all the IMS pods here getting, in the running status. So since they are running, we can go back we can see here that IMS is also successfully deployed. And day one is also done. We can add a couple of users here in IMS. One user is named Jack. I'm adding it as a part of day two action. One user is named Jack. I'm adding it into IMS. And I'll be adding another user called Joe. So this is the user Jack and this is the user Joe. We have done IMS day two also. I'll log in into the IMS DB pod once to show you that these two users have been added to the IMS DB. So I've logged into the pod now. So you can see both the users, Jack and Joe, that has been added as a part of day 2 in IMS. So with this, our deployment and configurations of the 5G is done. We can go to the 5G scenarios, where the first scenarios is the control plane, where we can register the user equipment with our core. So first I'll open the RAN logs. Our control plane trigger is a REST API here. So let me trigger the registration procedure. So here I'm triggering the attach procedure. So it is triggered successfully. I can show you the logs as well. So after the successful registration, core would have assigned a PDU session IP for the user equipment, and we can see it in the RAN logs over here. Let me scroll up. So since the registration is successful, you can see here that the PDU session IP address is 6060.0.1. So the user equipment UE is successfully registered and is now enabled to access the data network. Next, let me log into the UE pod so that we can start. Yeah, this is the aim. This is the core AMF logs where it says that registration is complete and successful. Right now I'm logging into the UE pod. And this is inside the UE pod. And you can see that the 6060.0.1 IP has been assigned to UE. So now our UE is enabled to access the data network. Now I'll also log in into the core's UPF pod to show that UE is accessing the data network through our core's UPF. I've started a TCP dump here in UPF. So let's get back to UE. And we'll be testing 3 types of protocols. And the first one is ICMP, for which I've started a ping to canonical.com. You can see here that the ping has been successful. Let's also check the UPF TCP dump to see that the packets are going through this. Yes, you can see in the UPF tab that 6060.0.1 the packets are going through. So the ping is ICMP is successful. So the next protocol we'll be testing is TCP, and to do that I'll be using wget. So right now I'm doing wget canonical.com, and that is also successful. If you can see here, the index.html is downloaded. And we can see in the UPF as well that it is going through UPF. And the next protocol would be UDP. And to test it, I'm going to be using a tool called Netcat. I'll start the Netcat client inside the UE pod and the Netcat server in another server, this 1045.4.131. So this is that server where I'll be starting the Netcat server at port 4060. So here I've started the Netcat server. Let me go back to the UE pod where I can start the client as well. So I've started the client as well. I'm typing out a message, welcome to demo, and I've sent it. This is the server, Netcat server, where we can see that the message has arrived through UDP. I can also show you the UPF logs. You can see in the end that it has gone through UPF. So with this, our internet data traffic testing is done. Our UE is able to contact internet through our core. So let me next move on to the SIP calls from UE. So this here is the list of IMS pods where we can see that the PCF IP, which is the IMS IP, as 1045.28.46. Okay. So here as the SIP client, we'll be using PJ SIP. It is already installed in the UE. So I've opened a configuration file for the user jack, which we added as a day 2 in IMS. So this jack is configured inside UE pod. And we'll be using another server as another SIP client sitting behind IMS, and we'll try to make calls between them both. Now I'm in the other SIP client, the other server, and this is its configuration file. You can see the name Joe here. Okay, since the configurations are done, we can make SIP calls between them. Before doing that, I'll also start TCP dump. I've started to TCP dumps UE OSM RAN and UE OSM IMS. From UE, inside the UE pod, I'm taking a TCP dump, and in the other SIP client, I'm taking another. So let's start the registration of the user inside UE pod. So you can see here it is connected to the IMS IP, and this is a UE IP. And also, you can see that here the registration is successful. This is the IMS IP. This is the UE's IP. So you can see in UPF as well that the SIP messages are going through UPF. So now I'll register the other client as well. So you can see here that the other client is also registered. The registration is successful. So both our UEs are registered. We can go ahead and make SIP calls between them. So right now I'm calling Joe from Jack. It is calling. And I'm in the other SIP client, and the call has come through to here, and you can see it is asking press A to answer. So I'll answer the call. So it is saying from the SIP client that it is connecting and confirmed. We can also check the user in the UE. There also it is connecting and confirmed. So the call has been established between the two SIP clients. And also, so now we can go ahead and disconnect the call. So I have hanged up from the UE side. It is disconnected. You can see there. And I'll go to the other client as well. So the other client is also disconnected here. So you can see here in the UPF that the packet has gone from 6060.1 to the other end. The buy has been sent during the hang up, and the other side has replied with 200 OK. So with this, our testing for SIP calls also is done. Let me open up quickly the PCAP files for you so that we can see the packets that has been transferred between both. So you can see here that the registration messages have gone, and also the invite messages. So these are the RTP packets that has been transferred between both the users. You can see here that these two are it is going from the UE to the other side, and from the other side to UE. These are the RTP packets, and finally the buy and 200 OK. This is the UE capture, And I can show you the other capture as well that we took from the other client, where here even you can see the registration messages and the invite 100 trying 200 OK messages. You can see the usernames also here that we used Joe. And also you can see the RTP packets flowing between both users, and finally the buy and 200 that has been transferred. So with this, we come to the end of our demo. So we've shown you the core RAN and IMS deployment and their configurations successfully, and also the 5G scenarios of registration and data transfer. So thank you. If you have any questions for us, Anand and I would be happy to answer it.
Okay, there were a number of questions in the sidebar, but we are actually, I think, running a little bit behind. Is that correct, Sylvia? We were supposed to move on to the panel session, I think, about 10 minutes ago.
We can use the panel for people to ask those questions, those pending questions. I think a number of them got answered on the chat anyway, and those that didn't get an answer, they can be raised again now during the panel.
Yeah, that sounds great. So what I'll do is just ask the other panel members, all of the presenters today, to be available at this time. Take your mute off, and what we'll do is, since there might still be a couple questions related to Tataelxi's demonstration, I'm going to allow for that, and let's make sure we get those questions answered. And then I had some general questions for the panel, but we seem to have a very active audience participation today, which is fantastic. So we'll start by asking the audience to close out their questions to Tataelxsi, and then we'll move on to the panel. So any remaining questions for Tataelxsi? I think there were some requests for sharing the network slice packages, and so I think you've already addressed some of that.
Yeah, I think most of them are addressed. All of them are addressed.
Okay,